So, in this paper, guys, we'll be going through the International GCSE Maths A Paper 1H. And what I like to do, I like to go through pretty much everything step by step. And usually, what that means is that I go through every question and I do as if I was a student. If you guys like to go ahead and do this or watch this completely, I say just hit the play button and just keep going. Or you can pause it and do every single question as it goes along, so you can kind of test yourself. But if you're doing this for revision purposes, just sit back, get some popcorn and let's have a look. So let's do the first question. So number one tells us that a plane flew from Madrid to Dubai. The distance the plane flew was 5,658 kilometers. The flight time was 8 hours and 12 minutes. Work out average speed of the plane. Now, with these kind of questions, we got speed, distance, and time. So I always think it's best to always write down the formula. So here's the formula for speed equals distance over time. And here they give us two pieces of information. They give us the distance at the top and time at the bottom. So let's write them both down. Now you'll notice that for the time, it says 8 hours and 12 minutes. What I like to do is write it as 8 hours plus 12 over 60, because we know there's 60 minutes in a whole hour. So when you do that, this will give you pretty much what's needed. For distance, we just write as it is. So you can put this in your calculator and you get about 8.2. But I like to put straight into this formula. So replace D with 5658 and replace T with 8 plus 12 over 60, or the answer in your calculator. And when you do that, you should get roughly 690 kilometers per hour. Yeah, that's it for the question one. Now for two, it says here are the first four terms of an arithmetic sequence: 85, 79, 73, and 67. So already you can see that it's going down by 6, isn't it, each time? Now what they want is to find an expression in terms of n for the nth term of the sequence. So here's a nice trick. What I usually do, to find the nth term, first things first, always go back from 85. So always go back from the first term. If you know it's going down by 6, so we're going to go across and add 6. That'll give us 91. And now all you do is literally, to find nth term, we say the nth term must equal, firstly, that 91 we just pulled out, minus the difference, so 6n. Okay, question number 3. So the diagram shows the shape ABCDE. The area of the shape is 91.8, and they want us to find the value of x. Alright, so typically these kind of questions, what I like to do is I like to always partition this or split this up into easier shapes. So I just split it around over here. Over here you can see that you got a rectangle at the top and a trapezium at the bottom. I mean, you could split it further if you want to a square or to another rectangle and a triangle, but this is good enough. So let's pull out the rectangle to the left, guys, and let's put the x and the a on the top and side respectively. Now, because this question gives us information about the area of the shape being 91.8, we should basically find the area of the rectangle and the area of the trapezium. So that means the area of this rectangle is 8 times x, which is ax, and that's done. So now let's go to the trapezium and do the same thing. So here we got the lengths of x at the top and 13 at the bottom, because you can see it from here. Now all we need is this vertical height here. Now if you look over here, to work out this height, if the whole thing is 14 across and this length chops at 8, that means the difference of 14 and 8 must just be 6. And that's it. That's the 3 pieces of information you need for a trapezium. Now if you remember, the area of the trapezium formula looks like this, where A and B are basically the parallel lengths. So the top and bottom are A's and B's. So it's x and 13. And the h is 6. So if you put that into the formula, you should get something like that. And you can simplify it further. If you got 6 here and 2, 6 over 2 is 3. So you times it by 3, this whole thing. So that means that the area of this shape is just 3 times x plus 13, which is basically 3x plus 39. And yeah, now we combine them both, because we know the total area is 91.8. You could say, if you add both of this, 8x and 3x is 11x, plus 39 gives us 91.8. And then just subtracting 39 across, you should get 52.8. And then to get x, guys, divide the right side by both sides by 11, and you're left with 4.8. That's it. That's the x we need. So number 4. Now on a farm there are chickens, ducks, and pigs. I'm not a big fan of pigs, guys. The ratio of the number of chickens to the number of ducks is 7:2. The ratio of the number of ducks to the number of pigs is 5:9. So notice how they got chicken and ducks in the first line, and then ducks and pigs. So this is a 3-way ratio. So we're going to make it 3 ways. Now there are 36 pigs on a farm, and they want the number of chickens. So let's just go ahead and just put an order of chickens, ducks, and pigs like that, yeah? That's what we want. And let's drop down 7:2 on the first line, and then on the second line, drop 5 to 9. That's exactly what's needed. Now here's this trick, yeah. To get a three-way ratio, you got to firstly find basically the common value between for the ducks. If you got 2 ducks and 5, if you time, all you need to do is basically multiply up and down by what they don't have. So times the top line by 5 and the bottom line by 2. Reason being, so that way you can kind of match them all up on the same ratio length. So if I did that, if I times the top set by 5, you should get 35, and then 2 times 5 is 10. If you times the bottom by 2, you get 10, which you already have, and 9 will become 18. So that's it. So this means now we've got everything on the same level playing field. And it tells us that there are 36 pigs on a farm. So notice how you got 18. If you double this, you get 36, right? So if we times the whole ratio set by 2, we should now get 70 to 20 to 36. And I think we're done. So we can see there are 36 pigs there. There are 20 ducks, and there are 70 chickens. That's it, yeah? That's 4 done. Alright, question 5. So expand and simplify all of these guys. So to expand this, let's focus on the first set bracket. It just says 3x times the inside. Well, 3x times 2x is 6x squared, and 3x times 3 is 9x. Now, notice, be careful with this minus sign here. So you can do minus x times everything inside. Minus x times 3x, well, it'll just be 3x squared. And minus x times 5 would be minus 5x. And that's it. Now, before you do, you have to always collect like terms, yeah? So notice how you got the x squares and you got the x terms. 6x squared minus 3x squared is plus 3x. And 9x minus 5x will give us 4x. Yeah, that covers that part. Now for B, make T the subject of the formula P equals AT minus D. Alright, so these kind of questions, I'm not gonna lie, never like these ones. But my recommendation is that when you want to find a certain letter subject, put this entire set of terms first. So rewrite it as AT minus D equals P. So just swap them around. So that way T stays on the left side, yeah? Now all we want to do is get everything that's away from T first. So let's move minus D across. So plus D across. So you get AT equals P plus D. And lastly, to separate these two, just divide A across. So it looks like that. Simple and done. Now for next one, given that W to the power 5 times W to the power n over W power 3 equals W to the power 10, work out the value of n. Now the rules is, when you multiply terms with the same base, so W is the same base, you add the powers. If you divide, you subtract it. So you're just going to do W to the power 5 plus n minus 3. And it has to equal W to the 10. Now because the bases are the same, this means that the top line, the powers must be equal. So 5 plus n minus 3 reduces to 2 plus n, and that has to equal 10. Therefore, n has to be A. Yeah, easy. Now 6. So Grace has a biased 5-sided spinner. So it looks like it's biased, but it kind of looks the same here. Now Grace is going to spin the arrow on the spinner once. The table below gives the probabilities that the spinner will land on either red or blue or green or orange or pink. Yeah, so they also got those as well. The probability that the spinner will land on orange is 3 times the probability that the spinner will land on pink. So let me take this on the next page. It's a bit easier. Yeah, much nicer. Work out the probability that the spinner will land on an orange. So first things first, with rules of probability, we should know that the sum of all of these guys has to equal to 1. That's very important. And now what I'm going to do to work out the rest, let's go ahead and add up these 3 probabilities, red, blue, and green, because we're going to get to this statement in a second. Yeah. If you add those 3 in your calculator, you should get roughly 0.4. Now it tells us that the probability that the spinner will land on orange is 3 times the probability to land on pink. That means if pink was x, orange would be 3 times that, so 3x. Nice. Now, to work out this, remember we just said that if we added all of these together, it has to equal 1, right? So let's do it. You're going to have 0.4 plus these 2 terms, which will make 4x, and that's equal to 1. Now rearrange this, subtract 0.4 across, you should get 4x equals 0.6, and dividing 4 across, you're going to get that, 0.15. So we know what x is, but they want orange, right? So they want 3x. So in your calculator, times the result by 3, you should get 0.45. Nice. Now Grace spins the arrow on the spinner 150 times. What that means, you can do 150 times whatever they want, yeah? They want blue. So the spinner, they work on estimate for the number of times the spin lands on blue. So all you go do is 150 times the blue probability, which is 0.12. Okay? And then doing that, you should get an answer of 18. Okay, number 7. So they give us an inequality and they say y is an integer, so y is a whole number. Now write down all the possible values of y. Okay, so what I like to do with these type of equations, with this inequality, sorry, if you got like a number in front of the y, let's go ahead and divide it by number because we like to see just y. So let's divide everything by 2. If you do that, you should get this. Okay. Now this tells us that y is pretty much every number between it, so it's between -2 and 3, but it includes -2 and it excludes 3. So that means it should be -2, -1, 0, 1, and 2. Now for B, they said solve the inequality 7t minus 3 less than or equal to 2t plus 31. So just pretend you got equal sign here, yeah? And let's write down here actually again. Now, I like to get t's on one side and the non-t value terms on the other side. So let's go ahead and move -3 across and 2t to the left. So we're going to plus 3 and minus 2t. So if you subtract 2t, it will look a bit like that. And if you plus 3, it will look a bit like that. So we've got 7t minus 2t less than or equal 31 plus 3. If you simplify that, so let's just move it a bit to that side, you should get 5t less than or equal than 34. Now just divide the equation by 5 and you have your answer. You could leave it like this or a decimal. It's all good. They don't tell you how to leave it in. Okay, number 8. So the table shows the populations of 5 countries. Here we got China, Germany, Sweden, Fiji, and Malta. And by far, guys, China has the biggest population without a doubt. If they added India, that would be the next closest one. And here we got Fiji and Malta, which have the smallest populations. Yeah, so ones with the lowest power are the smallest, biggest power, by far the biggest. Now, A, work out the difference between the population of China and the population of Germany. Give your answer in standard form. So that's it. That's the key takeaway. Now, what I like to do, anytime I work with certain countries, I like to underline them. So population China and population Germany. And I always like to circle the values I'm using. So in this case, China and Germany. Okay. Now, all you want to do in your calculator is just put these both in. So write 1.4 times 10 to the power 9 minus 8.2 times 10 to the power 7. If you do that, you should get a number like this, without the commas, of course. I just put the commas there because it's important to, just kind of, it's nice to separate them in 3 digits because that way you can read them more clearly. And to put something in standard form, all you got to do is literally underline every digit after the first digit. So circle the first digit and just underline the rest. Here you can see that there is 9 digits all together. And what I like to do is once you do that, write equal and copy the pretty much every non-zero term. So 1. So copy the first one, 1, and write a point. Then write 318. So this is how standard form works. And you write times 10 to the power something. Now that power term is dependent on how many digits there are after the first number. So after 1, there are 9 digits. So it's 10 to the power 9. And that's it, guys. That's literally standard form done. Now, next part, given that the population of Fiji is 1 over k times population of Sweden. So what I like to do is write this in algebraic terms. So this means population of Fiji, we call it F. Population of Sweden, we call it S. So what we have here is F equals S over k. Okay? They want us to work out the value of k. Now, all you want to do is just times k across and divide F, so swap them around. So you have k equals S over F. And now just put the Sweden and the Fiji population in the calculator. So you want to put basically this one and that one. So in your calculator, write, use a fraction bond first. Write 9.9 times 10 to the power 6 on the top part of the fraction. And on the denominator, write 9.1 times 10 to the power 5. And if you do that, you should get approximately 10 point something something, but it should round up to 11. And that's it, that's this one done. Now 9. So factorize fully 25a to the 4, blah, blah, plus 45a to the 9, blah, blah. Okay, so easy way to factorize this, guys, is to firstly look at the numbers first and then factorize the letters second. Now, looking at numbers, we've got 25 and 45. So we've got to pick a times table that fits into both, and the one that fits into both is 5, and that's the highest one that fits into both. Next, you look at the letters A, C, D, and A, C, H. Well, we can see that they both have A's and C's in common, so D and H are going to go inside the brackets. For the A's, you pick the minimum power, yeah? For A and C, pick the minimum power. So for this one, we can see 4 is the smallest for A, and for C, we got 3, which is the smallest. Now we put this big bracket and then put some information there. plus the second bit. So to put the right things in, we look at the first part, yeah, the first term. Now we divided by 5, so to make 25, 5 times 5 is 25, so we put 5 back in. For A's, we took all the powers out. For C's, we took 3 powers left, so we left with 4 powers of C. And D, we didn't even touch, so that goes there. For the second part, to make 45, 5 times 9 makes 45. To make 8 to the 9, we took 4 powers out, so left with 5 powers. For 3, well, that's exactly the same, so we write nothing. And for H, we didn't touch, so we put it back in. And that's it, guys. This is what you do. Now for B, it says solve 2x plus 5 all squared equals 2x plus 3 times 2x minus 1. Now, what you want to do is when you see a squared bracket, that means there's 2 of them, right? So let's put them down. So that means you got 2x plus 5 times another 2x plus 5. And now we're going to make that equal to the right hand side, which was 2x plus 3 times 2x minus 1. When you expand brackets, guys, you always do term by term. So we do, for example, 2x times 2x, then 2x times 5, and then 5 times 2x and 5 times 5. And you do the same over here, yeah? So 2x times 2x, 2x times minus 1, 3 times 2x, and 3 times minus 1. So doing the left-hand side, yeah? When you do 2x times 2x, that will give you a 4x squared. And then 2x times the 5, which that gives us a 10x. Next would be 5 times 2x, which is plus 10x again. And last time, 5 times 5 is 25. If you repeat the right-hand side, you should get 4x squared. Next, 2x times minus 1 is minus 2x. 3 times 2x is 6x. And last one, 3 times minus 1 is minus 3. Cool. Now, as always, we're going to collect like terms here. So the x terms on the left and the x terms on the right. Put the equal sign to balance it. So 10x plus 10x is 20x. So that means you got 4x squared plus 20x plus 25. On the right hand side, minus 2x plus 6x is plus 4x, yeah? So that means you got 4x squared plus 4x minus 3. Nice. So you always double check your signs, yeah? Now, nice little trick. If you got the same x squared terms on both ends or any term that's the same, like 4x squared, you can just cancel both of them out automatically here. Because you subtract it, it disappears. So you're just left with 20x plus 25 equals 4x minus 3. Now what I want to do, I want to subtract 4x across and subtract 25 across. So you're going to be left with 16x equals minus 3 take away 25 is minus 28. And therefore x is going to equal minus 28 over 16. And if you want to simplify that, you don't have to, but you'll basically get minus 7 over 4 or x equals minus 1.75. I will just stick to the first one because it doesn't tell you to simplify answer. But yeah, that's our 9 done. Right, number 10. So Jeffro has sat 5 tests. Each test was marked out of 100, and Jeffro's mean mark for the 5 tests is 74. Cool. So if the average was 74 for basically 5 tests, that means the total is going to basically be 74 times 5. So let's write down here. 74 times 5 equals 370 marks for 5 tests, yeah? So it's always good to know exactly how many tests it was for. Now, for next line, guys, it says Jeffro has to sit 1 more test. Let's call this 6th test X, yeah? So that's your 6th test. And that's also been marked out of 100, okay? Jeffro wants his mean mark for all 6 tests to be at least 77. Okay, so what he's trying to say here, he basically just wants 77 times 6, right? So let's kind of put all this together. So far, he's on 6 tests, yeah? So he's got a total of 74 times 5, which is 370, plus the x, it should look like that. And now it has to be at least 77 times 6. That's what it needs to be, right? So the question is, work out the least mark that Jeffro needs for the last test. Well, we basically got the equation ready. So all you do in your calculator is write 77 times 6 minus 370, and you should get x greater than or equal 92. So he needs at least 92 marks. Cool. That's a lot of marks. Not bad though. Now, number 11. So here we got root 2 times 16 and equals 2 to the power x. Find the value x. For this kind of questions, you want to work in bases of 2, so 2 to the power of something. For the first part, because you got square root, that means 2 to the power half. And for 16, that's 2 to the power 4. So it should look a bit like that. And it has to equal now 2 to the x. And this is easy. When you're timesing things with the same base, like 2, you add the powers. So half plus 4 is basically 4.5 or 4.5. Yeah, and that's our A done. For the next one, we've got 11 to the power of minus 6 or bracket to 5. So that means you multiply the powers, yeah, when it's like that. And it's over 11 to the power 4. And if you're dividing, just like last time, you subtract the powers. And that's supposed to equal n. So if you set that up, minus 6 times 5, take away 4, you should basically get something that's written like that. And then minus 6 times 5, if you actually work it out, you get the n value. That means n is minus 34. Sweet. All right, number 12 now. So looks like we're almost halfway. Number 13 is the halfway mark. So let's go, guys. Where are we at? So diagram shows a sector of a circle with radius 7. So the radius is over here, guys, yeah? And angle is 50 degrees. They want us to work out the length of the arc. So the length of the arc means basically this bit right here. This is the length of the arc. So they want to work out this length here. Now, to work it out, all you got to do is realize that this arc is pretty much like a fraction of the circle. So it's like 50 degrees off the whole circle, or 50 out of 360. To work out length, I always do this. I always set it to equal the circumference, which is 2 pi r, times the fraction you're working with. Okay, so here's the circumference right here. So circumference, which is 2 pi r, times, in this case, instead of your angle, it will be 50 degrees. Yeah. So if you update the values, r here is 7 and angle is 50. So it should look a bit like this, 50 over 360. Then you just bust this all into the calculator and then keep it to one decimal place, which is going to be 6.1. That's it, 6.1 centimeters squared. Done. Now 13. So you got expand and simplify 4x times 3x plus 1 times the whole of 2x minus 3. And they want us to show you working clearly. Right, so I prefer to always work with the last two brackets here because it helps a lot. So let's have a go at this, yeah? So let's go ahead and lay this down properly. So rewrite it over here. Now, when you try to solve this, always work with these two first, yeah? So let's do this step by step. So I'm going to keep 4x over here and put a new bracket here. So we got 3x times 2x, which is 6x squared. Next, you got 3x times minus 3, which is minus 9x. Next, you got 1 times 2x, which is plus 2x. And the last one is 1 times minus 3, which is minus 3. Cool. And then we want to tidy this up here. So I'll put therefore signs. So you got 6x squared is fine. You want to collect like terms with these two guys. So minus 9x plus 2x is minus 7x. And the last one is minus 3. Cool. And finally, just literally open up the bracket. So 4x times everything inside. That's going to give us 4x times 6x squared, which is 24x cubed. Next, 4x times minus 7x is 28x squared. Lastly, 4x times minus 3 is minus 12x. Nice. I hope I got this right, yeah? I'm going to double check this here, but I hope I got this right. And all right, number 14. So here is the number of goals that Henri's team scored one summer in each water polo match. So for example, in the first match he scored 5 goals, and then the second match he scored 8 goals, and so on. And then one time he scored 20. So this guy is pretty sick. Now find the interquartile range of the number of goals. Show you're working clearly. Now any question that involves median, upper lower quartiles, or even the interquartile range like we're trying to find, we should always find the middle value because it kind of helps partition the values, yeah? So the first thing first, to find the middle value, just count how many numbers there are. So if you count all this, there should be a total, well, let's count together. You get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 numbers. So we write 11 numbers here, yeah? And the trick is to always add 1 and then half it, yeah? That gives us the mid value. And if you half it, you get the 6. So it tells us that the 6th position is the middle value. So 6 positions here, so you got 1, 2, 3, 4, 5, 6. So yeah, so this is in fact the 6th position, 13. Now, interquartile range is like this, yeah? The formula for it is actually the upper quartile minus the lower quartile. So upper quartile means the next middle value. So we can do this visually now, yeah? You got 5 numbers here on the right, so this is the middle value. You got 5 numbers on the left, so 9 is the other middle value. So this is the lower quartile. This is the median, and this is the upper quartile. So of course, they just want the difference between those two, right? So it's upper quartile minus lower quartile. 16 take away 9. Let's write it down. And that's just going to give us 7. So that's it. That's this question done. All right, number 15. So we have P, Q, and R are points in the circle with center O. Now TRV is the tangent to the circle R. So we're talking about this guy here. When you got a straight line here, a tangent hits at exactly 1 point, and it's always perpendicular to the radius. And if something is perpendicular, it means that this part is 90 degrees, always, yeah? And it's cool because you know that this part is 60, and therefore to make 90, you need to add another 30 degrees here. So this part must be 30. But we'll get to that soon. That's going to be one of our steps later. So other key information to tell us is that the reflex angle POR is 238, so that's this bit here, and the 60 degrees we know. But most importantly, they want the size of angle OPQ, which is here basically, and we need to give a reason for every stage of our working, and that is the annoying part. So we're gonna have to do that together, guys. So let's have a start. Now, what I like to do, I always like to start from something that looks quite straightforward. So let's always start with the center. Anything that adds up to either 360 or a triangle as a 180. In this case, we got a point. So we can say that because we know that this point, this angle is 238, if we have to finish it off, we can just find the difference between this and 360, which is 122. And we can give a reason for that, because you have to give a reason every step. We can say, and this is what I said earlier, angles around a point adds up to 360. And what point is that? That's basically the angle POR, which is this with POR, plus the angle above it as a 360. So therefore, POR is 122. That's cool. That's basically one mark for that. Another one you can do is basically work out this top angle up here, Q. Because it's like a spaceship size, all you have to realize that the angle at the center, so this 122, this shape here, this kind of wide part, is literally always double this skinny part here. So if this is 122, if you half it, you get 61. And as a reason for our working out, we can just say, okay, that's true. But the real reason is since angles at the center is twice the angle at the circumference. So always remember that, guys. Yeah, wherever this is, it's always gonna be double the part at the top, and that helps a lot. Now, one more part when we saw this earlier is the tangent line. Yeah, we know that the tangent makes 90 degrees. It's perpendicular to the radius. And the reason behind it is that the angle between a tangent and radius is 90 degrees. So therefore, if that's ORV, which is 90 degrees, that means ORQ is 30 degrees. And yeah, so now at the moment, we have pretty much everything we need. And how can we get X? Well, let's have a look, guys, yeah? We literally got a four-sided shape. If you think about it, this is a four-sided shape. And in a four-sided shape, it must always add up to 360 degrees. Here we got 61, X, this big 238 and 30. So let's put it over there. And it must sum up to 360. Now just literally make X subject, guys. Subtract, add all this up and then throw it to the other side. And you should get 31 degrees. Yeah, that's it. That's this big one done. This is the question that's always tripping me up. So it took me a while to kind of understand it and figure out. And I won't be surprised if it takes everyone else a while. But always remember all the properties, guys. Yeah, and if you're not sure, I've literally got a video on this kind of on circle theorems and geometry. So check it out and see how much you guys can pick up. Yeah, if you need any help, let me know. But yeah, let's move on. So 16. Use algebra to show that the recurring decimal, it looks like that, is a fraction. Now, for every recurring decimal problems, always write in algebra terms. Yeah, we always let this recurring decimal roll out, and we say let x equal 0.28131313 and so on, endlessly. That's how it should be. And the trick is to always multiply this set by tens on both sides. So if you multiply by 10, for example, you're going to get 10x on one side, and you get 2.81313131. And we're going to keep doing it again. Let's multiply by another 10, and you should get 100x. Now the point of this one is that you basically have to capture when does it start like copying itself. So for example, if you look at the x, you can see that the 1, 3 occurs here, at the third or fourth decimal place. It goes on. Same for this one. If you look at 100x, 1, 3, 1, 3 occurs at the fourth decimal place. So the main idea is to basically have this sorted out. And if you do, you can now subtract the two equations. Subtract equation 1 against equation 2. If we do that, we'll end up with 99x. Okay, so that's what I would do over there. And 99x. Subtract this in your calculator, get that. And then finally, divide 99 across, and you get this value. And then, of course, you can put this in your calculator to get exactly 557 over 1980. And that's it, you've shown it. Alright, 17. Using algebra, prove that given any three consecutive even numbers, so let's just write what that means. If I let n basically be the first even number, yeah, that means the next one should be n plus 2 and n plus 4. So you keep adding 2's basically. So here's our three consecutive even numbers. Now it tells us that proving given any three consecutive even numbers, the difference between the square of the largest number, which I'm talking about this one here, and the square of the smallest number is always 8 times the middle number. So what that means in actual words is this. The biggest number squared minus the smallest number squared must be identical to 8 times the middle number, which is this one here, n plus 2. And that's how it should look like. So the reason why it's a triple equal sign is that I'm trying to show that if I work with the left side, I should eventually get the result on the right side, yeah? So we're basically going to leave the right side alone, guys, yeah? So let's go ahead and expand the left-hand side, yeah? N plus 4 squared minus n squared. If you do n plus 4 squared, we should get, n squared plus 8n plus 16, okay? And n squared is just n squared. Now we can go ahead and cancel out these two in it. So just doing that right now, you just left with 8n plus 16. And this is easy. If you factorize 8 out, you get the result. And there's not much to this, that's all it is. For any single proof type question, you always get something that involves even numbers or odd numbers. So it's always good to kind of always write exactly what that means in terms of n, and it helps a lot, trust me. So let's move on to 18. So the table and histogram give information about the distance traveled in order to get to work by each person working in a large store. So for example, in the first one, it tells us that we got 40 people that traveled between 0 and 10 kilometers. So 0 meaning they could be next door, and they could be up to 10 kilometers away. Whereas in the last set, you got 30 people that live literally far away. Now, so A to B, complete the table and histogram. Now, usually for these kind of questions, guys, yeah, I always like to add two more headings. Both of them, the two of them are class width and frequency density. Frequency density is literally the height of the histogram, yeah? And class width is just the difference between these numbers. So this is easy to calculate. So class width, if we do it right now, 10 take away 0 is 10. And then for the rest of them, you get 5, 5, and so on. So you should get all of these numbers, right? Now, frequency density is literally like, you can kind of think of this like a shape, yeah? If the frequency is the area of the shape, this rectangle, then the class width is this length, and frequency density is the height. So it'd be base times height. If the area is 40, to get the height, you do 40 divided by 10, which is 4. And then do the same for the bottom. We'll get to that one in a second, yeah? So 40 divided by 10 is 4. So that means immediately we know that this height was 4. And we can kind of just see the lines here. You got 1, 2, 3, 4. So it checks in. So just put all the numbers in. You should get something like that. And that's important, guys. When you do histograms, always label the numbers, yeah? It helps a lot. Now, what's next? So now we know the height of things. Why don't we just fill out the frequency density here? So the second one is 7. Next one is 7.8, 5.6. And last one, which I should have written earlier, is 1. So last thing is to work at the frequency. So using the idea where you treat the frequency like an area of a rectangle. First one would be 5 times 7 is 35, and the rest two in your calculator, you get these numbers. So last part is to basically finish up the histogram. So we can see that the first 4 histograms have been completed, and they represent the first 4 rows, yeah? That means the last row, after 30, so after 30 to 60, is not done. So that's what we need to do. Well, we know that it has a frequency density of 1, so the height must be 1, and it has a width all the way across. So it'll just be like a straight bar, 1 all the way across. So kind of like this, all the way across. And that's it. That's pretty much our histogram done. Now for the last question, it says one of the people working in the store chose at random. So this is a straight up probability question. Work out an estimate for the probability that the distance traveled by this person in order to get to work was greater than 25. So before I do anything, let's work out firstly how many people were actually involved. So if you add up your total frequency, just add up all these numbers in the calculator, you should get 200 people, right? Now let's change the page for a second, yeah? I also want to keep the key information. So they wanted greater than 25 kilometers. So they're talking about after this bit, yeah? So this block, it's literally cut in half. So I'm going to highlight this yellow and that one yellow. And if you cut this in half, if we know that in that range 20-30, there was 56 people, half of 56 is 28. That's how many people there were. And we know in the bottom row, which is the last one, there was exactly 30 people. So therefore, altogether, there was 58 out of 200. And that's your answer to the probability. Nice. Okay, number 19. So let's check it out. Here we got a Venn diagram which shows a universal set E and sets A, B, and C. So that's what we got over here. Now it tells us that these numbers represent the numbers of elements. So what that means is that, for example, if you look at 12, it's not the number 12, but in fact it's like 12 different bits inside, 12 different elements. So you can think of 12 different stuff here. Same for the rest of things. Now the question wants us to find, at least in part 1, the number or the total number of elements when A unites with B. So A unites with B is basically all of A and all of B, kind of like this, okay? And here they just want the number, meaning you want to sum up these numbers, guys, yeah? So be careful. Don't count how many there are. Don't say there's, okay, 1, 2, 3, 4, 5, 6 elements or 6 things. That's not true. There's altogether, you know, if you sum up, there's altogether 45 elements when you add them up. That's what they want to see. Now for part 2, they want to find the number of elements when you have not A intersecting with not B. Not A means basically everything outside A, yeah? So we're basically talking about, if I said not A, I'm talking about 9, 3, 4, and 8. And not B is basically everything outside B, so like 12, 10, 4, and 8. Okay, this is basically not A. That's this part, and not B is this. Okay, so you can kind of see that's what they want. But they want the intersection point. In other words, when did they overlap? Well, they overlap at 8 and 4. So the total elements would be 8 plus 4, which is 12. Now finally, for part 3, they want to find the number of elements intersecting when A and B intersect, and then that uniting with C. So, okay, so it's a bit crazy. So A intersecting B is basically this middle part here, yeah? So it looks a bit like this. A intersecting B. Now you want to find the green one, so C as well. So C is basically the whole circle, which is this. Now uniting means, again, everything that's been highlighted. So we're talking about 5 plus 6 plus 10 plus 4 plus 3. Remember, you don't do it twice over, yeah, because it doesn't work like that. It's just exactly, you just count exactly as it appears once. So you, in your calculator, adding all these 5 different numbers, you should get 28. And that's literally it for this question. This is a tough question, I'm not gonna lie. This Venn diagram, it can be a bit tricky. So just practice, yeah, and never give up, guys. So let's move on to 20. Now P equals T minus W over Y. T is 9.7 correct to what there's a place, and same for the rest. Here they want us to find the upper bound for P. Now to find the upper bound, guys, all that means is that you want to maximize the top of a fraction and minimize the bottom. So upper bound for the top over lower bound for the bottom, kind of like that. Now the reason why we do that is because you want to find the greatest ratio, yeah, the greatest divide. But for subtraction, if you want to find the upper bound for T minus W, it's kind of the same thing. You want to find the widest gap, so the upper bound of T minus the lower bound of W. So that's what they want. So they want the biggest T value, smallest W, and smallest Y. Now, when it comes to bounds, you have to put this in intervals, yeah? So let's look at T, for example. T, to find upper and lower bound, all you do is take 9.7 and stick a 5 like I did, and then subtract go back by 1 from the 7, so it looks like that. And then you repeat the same for 5.9. You get 5.95 and subtract the 1 by 9, you get the lower bound. Same for this one. If you got just a whole number, just stick a 0.5, and then subtract that by 1, you get 2.5. So it's that easy. And therefore, to get the right values, the upper bound T, so you're talking about this value here. This is your upper bound of T, this is your lower bound of W, and this is your lower bound of Y. So just put this in the calculator, guys, and eventually you should get 1.56. Hopefully, yeah. I mean, hopefully he's right. I'm gonna double check it, but yeah, that's it. So moving on, 21. Given that x equals all of that, and then y equals something similar, find an expression for x in terms of a. Ooh, give your expression as a single fraction in its simplest form. Okay, cool. So they want you to basically substitute all of this into that one, so you can have a fraction and a fraction, yeah? So that's how it's going to look like. So what I'll do is I wrote it out like that. I had the x one, 5 over 9 with the y term inside, plus 5. And now, before you even consider multiplying out, you can, but I don't recommend it. What I'll do, I want to firstly clear this fraction, 5a minus 2. So what I did, I times up and down by 5a minus 2. And then when you do that, you're going to stick 5a minus 2 to the top, to the 9 times 5, and then to the 5 as well. And then this would cancel out. So look a bit like this. Okay, you'll notice that this has been cancelled out and everything else gets a 5a minus 2. And yeah, now you just expand carefully. So top line, you do 5 times the top, which you get 25a minus 10. 9 times 5 is 45. And 5 times that second part gives us 25a minus 10. Now, tidy up the bottom line. 45 take away 10 is 35. And you should get pretty much 25a plus 35. And same, and the top should be fine. And that's it. Because remember, they wanted a single fraction, yeah? And that's what you got. And then, oh yeah, I forgot. You can actually divide it by 5 as well. So divide it by 5 because everything's in 5 times table, and voila, guys. That is your answer. If you left it here, you won't get a mark. You need to divide by 5. So 22. Right, this is the question. Okay, this one has been giving me trouble, and I realized there was such an easy way to do this because it's been a while since I did a exam paper walkthrough on IGCSE Higher. But let's check it out. So the diagram shows a triangular prism with a horizontal base. Okay, here's your base. And then it tells us that all these, so 12 is basically all the triangular lengths. Okay, AB is 10, and so on. Calculate the size of the angle between AD and the base ABF. So what that means is first you draw a line from A to D, like that. And then the base, you have to understand what that means. That means the ground part. So let's draw this down, and then we connect this triangle across. So this is your base. So the angle they want is this part here. That is the angle we need to find. So we have our right angle triangle, and I'm going to label this midpoint M. And all we need to do now is literally work out two lengths. So I'm going to try and work out DM and AM because I feel they're much easier. And we can use SOHCAHTOA to get X. And that's it. That's the main idea. So let's pull out the triangle which has DME. Yeah? So this, by the way, this is our half length. If we know that the full length is 10 across, then this short length is 5 here. So let's pull it out right there. Now, to work out DM, we could use Pythagoras. So we got DM squared plus 5 squared equals 12 squared. And, you know, just put this in the calculator. 12 squared take away 5 squared. And square root, you get root 119. My advice, keep your exact answers. Yeah, do not write your random decimals. It's better to keep the square root value because you're going to use it for later. Now, that's the DM part done. Let's find AM, yeah? So we're going to take this line here. So we're going to take triangle A to F to E. Yeah? So I'm going to pull it over there. And you know, all of this is 15 across because it's there. And this half length is 5. That's why we got 5 there. Doing the same thing, we're going to do Pythagoras. So 5 squared plus 15 squared is AM squared. And then square root it. Just keep the value 250. Just keep it on the root form, and that's what we're going to use. And now, because we got these two triangles sorted out, we can go ahead and pull out the main triangle of interest, which is ADM, yeah? So and with angle X. So DM being up across and on the opposite, and AM being adjacent. Just like that. Now, because we know our values, we need to basically pull out SOHCAHTOA, yeah? And we need to realize that with SOHCAHTOA, we need two things, yeah? And OH or A. So DM is currently the opposite because opposite angle, and AM is the adjacent, yeah? So therefore we need OA, so we need TOA. So let's just pull out TOA. TOA means tan of the angle, so tan X, and it's going to equal opposite over adjacent, so DM over AM. And now we just plug in the values. We plug in root 119 at the top, root 250 at the bottom, square root it, tan inverse it, and you get an angle of 34.6. And that's it, guys. It's as simple as that. Alright, question 23. So the sum of the first n terms of an arithmetic series S is 292. The second term of S is 8.5, and the fifth term of S is 13. Find the value n. Cool. So with arithmetic series, it's always good to know the formulas, yeah? So in here, we're dealing with the sum and the regular m term, which we're going to call un, yeah? So for the sum, this is how it looks like. Sn equals n over 2 times 2a plus n minus 1 times d. Here, a, by the way, is the first term, and d is your difference, and n is your position, wherever you are. The other formula they want is the general nth term, which we call by un. Here, you got the same thing, so it's actually a smaller version of the sum. Now, two components which is useful here. We want to try and figure out a and d is first before we do anything else. Once you work this out, we can go ahead and tackle this problem later, which is find the value n. So they tell us firstly that the second term is 8.5. All you got to do is replace the n from the un formula with 2. So this will be 2 and this n will be 2. Just like that. And it's going to equal 8.5. If I simplify this middle part, 2 minus 1 is just 1. So it would just be a plus d. equals 8.5. And that is one equation. Now, if we repeat this for 5 for when n equals 5, we're going to get something similar. Instead of 5 minus 1, you get 4d. That would equal 13. So now, pulling these two equations across, we can go ahead and use simultaneous equations to subtract them, or any other way to get the values of a and d. I prefer this way because you just got a already. It's already literally lined up for you. So now if we subtract these two equations, a take away a is nothing, 4d take away d is 3d, and 13 take away 8.5 is 4.5, exactly as you see. And now to find d, just divide by 3, and you get 1.5, guys. So that's a common difference, meaning every single number is going up by 1.5. If you got if you got one of the values, you could pick any other equation to get the a value. Okay, so let's pick this equation here, a plus t, because it looks like the easiest. If I replace this d 1.5, I can go ahead and just take away 1.5, right, to get a. So a is going to be 8.5 take away 1.5, which is 7, guys. And that's it. We've already found two components which will help us solve the question. Now, if you remember in the top line, it said the sum of the first n terms is 292. So we're talking about the sum formula here. So this Sn is going to equal 292. And this a and d values, well, we have them here. So it'll look a bit like this. Okay? So you got a is being replaced with 7 and d is replaced with 1.5. What we want to do now is go ahead and expand this crazy bracket. So you've got n over 2 times 7, which, well, you can cancel the 2's, which n times 7 be 7n, and then n times all of this, so n times n times 1.5. So what I'll do is do n times n is n squared, then you times it by 1.5 over 2, which will give us 0.75 n squared. N over 2 times minus 1 times 1.5 will give us that value here, 0.75 n. Hopefully this made sense. I think I might confuse you, but let me know if this part makes sense. Now all you want to do is you're going to notice that this is a nice quadratic equation, yeah? So let's go ahead and put everything on one side, just like that, and make it equal to 0. If you guys got this, let me know, yeah? And now using your quadratic equation or using your calculator, I'm going to use a quadratic formula because that way everyone can have a go. Here we set a to be 0.75, so I'll just write it down. So a is 0.75 is the first term, b is 6.25, and c is minus 292. If you put all of this into this formula here, and I use the plus, by the way, because if you use minus, you won't get the right value. We want a value of n, a single value, meaning it needs to be a positive whole number. Use the plus one, so cancel. Let me just put a plus. Then you should get a value of 16. That's it. If you guys got that, then well done. All right, 24 now. So we're almost done, guys. We've got a few more questions to go. So let's do this. So functions f and g are defined as the following. So you got a function of x. This literally means y equals, by the way, and a function of g. So they're both y equations. Find the composite function fg2. So this means when g goes inside of f. So what's that mean by inside? All that means is that you take this equation, you replace all of these x's with 7x minus 6. So it looks a bit like that. Fgx is literally going to now equal all of that. So replace all the x's with 7x minus 6. So cool. And then they want you to replace the x value now with 2. So it's going to look like this. And then all you got to do is put all of this in your calculator carefully. And if you did that right, you should get 247. That's it. That's literally how you do composite functions. Now, the main part of this one is literally the inverse function, yeah? We want to find the inverse function of f in that form. So what that really means, so you look at this f function and you say, okay, instead of fx, let fy equal x. So you're kind of doing some sort of reverse psychology here. So let fy equal x. And all fy means is that you use the f function and you replace all these x's with y's. So it looks a bit like that. So instead of 5x squared, you have 5y squared and so on. And instead of equaling it to whatever, you can equal it to x. Now all you gotta do is just rearrange it to make y the subject, yeah? So you're gonna have to use a little bit of completing squares soon. So first is first, let's subtract 7 across, yeah? So it looks like all of that equals x minus 7. Next thing I did is that I divided 5 across. So it looks like that. Divide 5 across, you get something like this. And now you need to complete the square. In order to complete the square, all we have to do, we look at the second term, the 2y, and we half this value to get 1. So next you're going to have y minus 1 squared, exactly like it is. and then you're going to copy the term and you're going to plus it by this bit squared, so 1 squared. So you take the 1, put it here, and you square it on the other side. Hope this makes sense. And let me know if this part makes sense here. That's the most important step. And now you're pretty much almost done, guys. So now we just square root both sides and then add 1, and voila, guys, you are done. And don't forget to put plus minus when you square root, yeah? Yeah, not much to this. Not much to this question. So let's do 25. Now, the diagram shows two circles such that the region R shown shaded in the diagram is the region common to both circles. Okay, cool. Oof, okay, I see where this is going. One of the circles has center O and radius 5. The other circle has center P and radius 4. So we're talking about these lengths here. Angle AOB is 50 degrees. Calculate the area of region R. Right. Okay, so let's take this on a fresh page. Now, what I like to do is that I like to redraw. Actually, first and foremost, let's draw a straight line cutting through the region. Yeah, that helps. So what we have here is that we kind of have a separate sector starting from here, cutting all the way across here. And for P, we have another sector cutting across all the way around here. So if I had to draw them separately, the first one will look a bit like that. Not as wonky, but yeah, it'll be OAB. And we're going to call this region R1. And I draw the same for P. Split it up and call this region R2, yeah? So what we have here, we have pretty much the information we need. If you see it like this, it becomes a lot easier, guys. So you can actually pretty much ignore this rest of this circle because you don't actually need the circle. You just need two sectors. And you want to work out the segments, yeah? Oh yeah, one note, R1 plus R2 has to equal the total region R, yeah? Because that's exactly what it is. So, main formula here to take away, guys, is that the area of a segment equals the area of a sector, which is all of that, take away the area of a triangle. So if you think about it, this little bit is the whole sector, take away that triangle on the left. That gives you that little extra mushy part. The general formula for the area of a sector is pi r squared times the angle over 360, and the area of triangle formula is half AB sine C. So this covers the general form. Now if I look at R1 as an example for the area of a segment, to work area of a segment, we can say this. R1 is going to equal firstly the area of a sector. We know the radius is 5 and angle is 50. So it looks like that. And by the way, this angle C is 50 degrees, yeah? This AB are both R times R. Because typically for a triangle, these two would be AB angle C. So in this case, basically A is 5 and B is 5. R is also 5, which is kind of nice. So you have basically R1 done. If you put this on the calculator, guys, you get a number that looks a bit like that, 1.33275. So that sounds easy. It sounds like we're going to get this done quickly. But if you look at R2 now, it gets a bit weird. I call this angle X for a reason, because there's no angle associated to it. And we can't just say it's 40, because if that's 5, that's 50. This won't be 40. It's not symmetrical like that. So what you do now, you do the same thing for R2. You have X over here, and you have X over there. Now the problem is we want to find out what X is. And to do that, we need to consider the first triangle here. Okay, we're going to use some sort of Pythagoras and work out this length Y, and eventually we'll get our answer. So let's do it step by step, yeah? Let's pull out this sector for a second. If we cut in half of 50 is 25, half of Y is Y over 2. If we use now SOHCAHTOA, we're going to have the opposite, which is Y over 2, and the hypotenuse is 5, right? So O and H. So that's going to be sine. So it's going to be sine 25 equals the opposite over the hypotenuse. We can simplify Y over 2 over 5. So we can do 2 times 5, which is 10. So Y over 10. Now to get the value of Y, just times 10 across here. So 10 times sine 25 is going to give us 4.226. That's basically this part done. So we've essentially found this value of Y and that value Y. Because remember, that it's the same length to split across. Now doing the same for the second triangle, because remember the key objective is to find X here. If we split this nicely across, the triangle will look a bit like that. X over 2, and our new Y value, which is 4.226, divided by 2, because remember, you're halving that entire Y length. Now, same thing applies here. We've got an opposite, which is 4.22. This side is the opposite, and this 4 up here is our hypotenuse. We're going to use sine again. Instead, it's going to be sine X over 2 equals that quantity there. So sine inverse this, guys, and then times your answer by 2. You should get 63.8, and that is the angle we exactly need now. Now, using this X value, plug into this R2 equation, yeah? Replace these X's of 63.8, and you should get this answer. 1.73009. Whew, almost done. And finally, remember what we said at the beginning, R1 plus R2 is the actual R value. Let's go ahead and add up these long decimals and then round it to 3 significant figures, guys. And you should get 3.06. Voila. I hope this helped you. This is definitely the hardest question in the paper, without a doubt. No, second hardest. You haven't seen the last one yet. Let's move on. 26, vectors. Now, what do we have here? So we're given a trapezium, right? And you're given the diagonals OC, AB, which intersect at point P. Cool. Find and simplify an expression in terms A and B for O from going from O to P. Show you working clearly. So let's pull this out for a second. And I'm going to try and explain this like the best way I can, yeah? So easy way to do this, guys, yeah? You want to basically find literally a vector O to P, yeah? So let's go ahead and find something related. Let's find O to C, because O to P is pretty much proportional to O to C. It's in the same root. So O to C, you start from O, you can go up 2A and plus 3B. So look a bit like that. O to C means 2A plus 3B. Now, for these kind of questions, you always need to find something else that sort of crosses P. So your only option is to find A to B. Now A to B means you're going to go back 2A, so minus 2A plus 5B. So that's the other equation. Now the next part here is to find an equation for O to P, exactly. We said earlier that O to P is proportional to O to C. What that means is that you can use a scale factor like K. So this means that it's like some fraction of that length, but we don't know how much. Like how short or long is it of O to C? It could be like half the length of O to C. It could be like 3/4 the length. I don't know. I'm going to guess it's like, I don't know, 4/7 or something. Who knows? Now that's one equation done, which is great. We need something like that. So if we expand this carefully, this means that it's literally K times 2A plus 3B. Now that's one equation. Now we need a second, okay? Now what I did here, because you have A to B, we can kind of just pick something out. Why don't we say, to go from O to P, we can go from O to A, and then maybe, yeah, so another O to P could be O to A and then A to P. That could be another route we can take. So let's do that. So what we're going to say, O to P could be 2A plus, and another scale factor, M of some scale factor of A to B. This quantity here is literally referring to the A to P length, because there's some fraction you need to get there of that A to B. Now all you want to do is just basically replace A to B with what we found, which is 2A plus 5B, and tidy this up. So what I did is I like to collect in terms of A and B, yeah? So you got 2A plus, if you expand this, it would be minus 2MA. So factorize out, you get 2 minus 2M, A, exactly what we want, plus 5MB. So you'll notice that you got your terms sort of lined up. So apparently this is another way to get O to P. If you look at the first equation, you have another way to write O to P. So you kind of have two literally different equations, but apparently they're both equal, which is good. That's what we want. And that's where, this is where the equation gets solved now. So now let's go ahead and just split this up. So what we want to do, we want to solve these, we want to kind of like line them up. So I'm going to say, let equation 1 equal equation 2. So it looks exactly like that. If we expand this out, we're going to have 2Ka plus 3Kb. It's going to equal that vector line at the bottom. And what you want to do, guys, you want to match up in terms of these vectors A and B. So look at vector A for a second, yeah? What do we have? You got 2K and you got 2 minus 2M, right? In terms of A, they're equal. There has to be some value K and some value M that makes them equal, correct? So that's what it is. Now, if you look at vector B, you have the same thing. You got 3K and you got 5M. Once again, if you match in terms of B, there has to be some value of K and M where they're equal. So that's when you're going to have to solve these guys simultaneously, just like other simultaneous equations. So next step is to multiply top line by 3 and top line by 2 because I want to match the K's now. So let's make it in terms of 6K's, yeah? And then when you do that, you have this equation here. Okay, so now they're lined up nicely. We can go ahead and solve this simultaneously. We can go ahead and subtract these equations. If you subtract the top and the bottom, the left line, 6K take 6K is 0, 6 take away nothing is 0, minus 6 take away 10M will give us minus 16M. So this is what you should get if you subtract these two equations. And finally, guys, solving for M, making M the subject, you should get 6/16. Okay, now you got M. Once again, for any simultaneous equations, pick any equation you like to get K. I'm gonna go ahead and pick I don't know what I picked, so I'm gonna just skip it. So what I pick? I picked this equation here. I replace this M value with 6 over 16, and I just divided 6 across to make K the subject. So a value of 5 over 8. And then finally, guys, because you got your K value, and we defined earlier what O to P was. Remember, O to P, we defined it as this equation here. All you want to do is literally replace this K value with 5 over 8, 5/8, and then expand it. So 5/8 times 2a will give us one result, and then 5/8 times 3b will give us the next result. And remember, simplify your final result, guys. And voila, this is it. Whew, this vector question was tough, and sorry guys, I got a bit tired towards the end, yeah, but this is pretty much what it should be. Let me know how you guys found this vector question, because this is definitely top tier grade 9 level question. Okay, even this is from an exam paper, this is still one of the toughest questions I've seen in vectors. But yeah, thank you for watching, guys, and you know what, if you enjoyed the video, please give me a like and subscribe, share with your friends, because it helps a lot, and your teachers, your parents, and your families. Please share this across so that way I get more hits. And soon enough, you're gonna see my channel, my website, where you guys can try out loads of problems, watch videos in an organized way. And yeah, other than that, have a nice day, and I hope you guys smash your exams. And I'll see you guys next time.